Welcome back, ladies and gentlemen. Weight.
Wait for what?
So the weight is the force of gravity. Weight is the force of gravity. So the little force of gravity, the green arrow we've been drawing down, it's the same thing as weight on Earth.
Yep.
Yeah. How do we calculate this? The exact same way. M times G.
Oh, I remember. Gee,
What
that's when the bowling ball was falling.
Yeah. What is my number? Well, this is the acceleration due to gravity. What is my acceleration due to gravity? What was that number?
It's always down, so it's going to be negative.
Negative 9.80 meters per second squared.
That's it.
So this G is going to always be that number on Earth.
Yeah.
If we're on Mars, it's different. And then our mass, we can get this, which means we can get this. Okay. So we are going to use the triple beam balance to do just that, to find the mass of our cart. So cart. Okay, and we're going to calculate the weight in newtons. Huh. You know, I'm actually going to call it 500. You okay with that?
Okay.
It's a little bit low, but that's right. Okay, so, and that was 500 grams,
Grams.
not kilograms. Mass is 500, 500 grams, which is the same thing as 0.5.
That's half a kilogram.
Okay, we use the triple beam balance. Oh my God, I cannot speak. To find the mass of your cart, calculate the weight in newtons. Okay, we said that weight equals the force of gravity, which equals mass times the acceleration due to
That
gravity,
looks
right?
like Newton's second law to me.
It is. Our mass is 0.5 kilograms times our acceleration due to gravity is negative 9.8 meters per second squared. Let's do it. 0.5 times negative 9.8 gets me negative 4.9.
That's about half a 9.8.
Yeah, negative 4.9 newtons.
So that's how much it weighs.
That's how much it weighs. Why is it negative?
Because the force of gravity is down. Sorry.
Yes.
I know
Okay.
what I'm doing.
Let's draw a free body diagram showing all the forces acting on the cart as it slows down at negative 1.2 meters per second squared. So at this point right here, so we want to know right now when it's slowing down. Okay. So free body diagram, that is with the dots, right?
That's the dot.
And we know that there's the force of gravity pulling the cart down towards the center of the earth.
And we know what the force of gravity is.
We just calculated it. Mass, force of gravity, mass times acceleration of gravity, negative 4.9 newtons. And this is the same thing as weight. If I asked for the weight, you could get it for me.
Yep.
Okay. Now, the next thing is the cart is not falling. It was when we picked it up here and dropped it, right? But it's not falling currently, so we know that the FUP,
The fup.
is equal in magnitude in opposite directions.
Newton's third law.
So equal in magnitude, but opposite direction, so just not negative, positive. Huh, cool. Okay.
What else we got?
It says, so what happened to the bubble when the cart slows down?
It went backwards.
It goes backward. So the bubble goes back. Okay, and we know it's a negative acceleration, right? The acceleration is negative 1.2 meters per second squared. Negative means it's slowing
down. Going in the positive direction and it's slowing down.
So we're going to draw that over here, right?
Yeah.
And we called this the force of friction.
Yep.
It's opposing motion.
And in this case, that's the only force that's not canceled out. So the force of friction is also going to be the net force.
Exactly. So our acceleration is going to be this way, and our force net is also going to be that way. And these are equal magnitude, opposite direction. They cancel out. It's almost like we ignore them. Okay?
What is the net force? How can we use Newton's second law to find the net force?
How could we do that?
We've got the acceleration.
Well-
We've got the mass.
We've got the mass, we've got the acceleration. Force net equals mass times acceleration, right?
Yep.
Okay, so our mass is 0.5 kilograms times our acceleration is negative 1.2 meters per second squared. And let's go ahead and do it. Well, what's 0.5 times, what's half of
0.6?
Negative 1.2, yep, that's gonna be right. Negative 0.6, sorry. Negative 0.6 newtons. Okay, so
Now, since the net force is equal to the force of friction, we know how much the force of friction is.
and this negative sign gives us a direction, right?
It does.
It tells us that it's this way. So it's 0.6 newtons, but this direction.
Yeah.
Okay.
Now, I noticed that we have the weight, mass times the acceleration due to gravity to give us the weight, but multiplying the mass times the actual acceleration of the horizontal acceleration of the cart, it's Newton's second law.
Mm-hmm.
Sweet.
Did we talk about the trick to remember what Newton's second law is? Like there's two things here, it's the second law.
Yeah. Oh, that's it.
Yeah, right, so we've got one thing here, two things here, this is Newton's second law.
Second law. I
Right.
like that. You know, I hadn't thought of that.
I like that. Okay, here we go. Homework. Okay, homework. I'll put these down below and you'll answer them on this assignment on Canvas. So you push a cart with a force of 12 newtons. I push a cart with a force of 12 newtons. How much force does the cart push back on you?
You know, that's too easy. I think, you know, if for giggles, they should draw a free body diagram.
Ooh.
And there's no friction, it's push. How would that be different? And could you put all that information on there?
Ooh,
I'm
I
sorry,
like
Miss
that.
Moore, that just occurred to me when I
No,
saw
well,
that.
we're gonna add it in there. Don't worry, guys. I'll put those words in what Mr. Boykin just said in word format. Don't
All
worry.
right, all right.
And then you're also gonna read page 139 through 141, and this section is titled Newton's third law.
Sweet.
Okay, go ahead and begin.